Hello students, welcome to the video lectures of speech and natural language processing. Today we will discuss about morphology and finite state transducers. What is morphology and what is finite state transducer? Before we discuss about them, let us have a recap of the previous video lecture what we discussed. We had talked about concepts like language modeling. So language modeling is the task of predicting the next word in a sequence based upon the words that have come before. Under language modeling, we have classified it into two. One is grammar-based modeling. Second is statistical-based modeling. So in grammar-based, it follows the formal grammar rules to understand and generate the language. In statistical, it tries to learn from the patterns through which we train it. That is about your grammar-based modeling and statistical-based modeling. So we have had some couple of examples which I illustrated in the video to make you clear with the concepts of grammar-based LM and statistical-based LM. So let us now further jump into the topic for today. So morphology. So morphology is the study of the internal structure of words and how they are formed from smaller units called morphemes. Then let us see at the definition of a finite state transducer. FST, that is your finite state transducer, is a computational model that can be used to describe morphological processes, such as the generation of word forms or parsing of inflected words. These concepts are fundamental in NLP, especially for tasks like tokenization, parts of speech tagging, and machine translation. So let us see one by one. First, let us discuss about morphology. Then we'll discuss about finite state transducers. So morphology. So morphology is the branch of linguistics that studies the structure of words. It focuses on morphemes, that is the smallest meaningful units in a language. So when I say this morpheme, so morphemes can be the base words in the sense roots we can say, or some affixes. When I say affixes means it might be a prefix or suffix or infixes. So we have some types in morphology. The first one is inflectional morphology and the second is derivational morphology. Let us see the definition. Inflection morphology deals with grammatical variations of words. Examples, tense, number, or gender. And derivational morphology concerns the creation of new words by adding affixes to a root word. Initially, the definition of morphology says that it's the branch of linguistics that studies the structure of words. So it focuses precisely on these morphemes. So when I said morpheme, I told you that the morphemes can be the roots or affixes. So when I say the root can be a base word. When I say affix means it might be a prefix or suffix or infixes. So to understand this inflectional morphology or derivational morphology, I'll just give you one example for inflectional morphology first. Then we go for derivational morphology. So for inflectional morphology, so consider a word and how we can make it to a plural. That means, suppose there is a word C-A-T, cat, and if you just add S for it, it becomes cats. So that is plurals. Then let us take another word that is walk, W-A-L-K, walk. And if you just add ed to it for past tense, it becomes walked, right? So this kind of addition of plurals or making it to past tense by addition of some ed, etc., is your inflectional morphology. So where it deals with the variation of words grammatically. So now if you see, by adding s to the example cat, it have become cats, that is plural. And by adding ed for walk, it became walked. That means it is dealing with some tenses as well. So in derivational morphology, the derivational morphology concerns the creation of new words by adding affixes to a root word, right? So the example can be, so if you say a word called happy and you just add any ess for it, what does it become? It becomes happiness. And if you suppose you take a word called do, do, and you just try to add some affix to it, that is un. Okay, so it becomes undo. Hope you understood this. So this is how the morphology works. So the key concept when we talk about this morphology are there shall be a root word, the core meaning of a word, and there shall be an affix to it. That means a bound morpheme that modifies a root, and there will be a stem, the form of the word before affixation. So let us take an example of run, and the root word is run, 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 and if you have an affix to it, that is it becomes running. If you add it ing form, and the form of the word before affixation, that is your stem. Example is run. That is, in running, before the morpheme have added an affix, it is run. So that is the stem. So examples already you have seen regarding the cat, that is it becoming plural and making some tenses, past tense of walk and walked, and verb conjugation can also be a part of this, that is run, running, eat, eating, etc. Clear, students? So then we talk about finite state transducers. So FST, that is finite state transducer, is a type of finite automation used to model morphological transformations. So the component that exist in FSTs are states, transitions, input and output alphabets. So a state is a finite set of conditions. Transitions means arrows between states labeled with pairs of symbols, input and output. Input and output alphabets are the input symbols correspond to morphemes and the output symbols represent transformed words. So let us try to understand this with an example. So now I'm trying to do a task called stemming. Stemming is nothing but to chop off the words. That is to cut down the words to its base form or root form. Suppose if there is a word called running, cutting it to the stemming of the running is run. Understood. So if you see this, as mentioned in the previous slide, the components which are present in finite state transducers are a state, transition, input and output alphabets, right? So taking these things into considerations, now we can see there is a task called stemming tasks. So let us consider an FST that performs stemming by transforming the word running to its base form run. So states, so first state is your start state. You can see here, which is already shown in the diagram. So this is the start state. Now what we are doing is we are taking run, okay, in our starting state. Then we write running at the end of the state. That means RUN will be written here. So this is RUN. Sorry. And then here we are trying to add NING running. Okay. So now you can understand from this, Q0 is its start state. Q1 is the intermediate state after recognizing the root. Q2 is the final state, that is output state. So transitions are from Q0 to Q1. So that is from this is the Q0. See, this is what I have written is run, RUN run. This is what I have written is NING running. So in order to add this NING to RUN. So this is the start state Q0. So the transitions are from Q0 to Q1. So input is run and output is also run. That is the transition from Q0 to Q1. Then from Q1 to Q2 transition, the input is NING. So Q1 to Q2, the input what we are giving is NING. Clear? So this is Q2. This is the final state. So now the process, let us understand the process, how it stemmed it. So input is the FST receives the word running. So transitions from Q0 to Q1, it matches the substring run and outputs run. And transition from Q1 to Q2, it matches the substring NING and outputs nothing. That is removal. So final output is, the result is run. So this is how stemming is performed by your FST. So basically, the what or how this FST work is, generally takes an input string and transform it to an output string. So by using this series of transitions, as of now, we have seen some Q0 to Q1, Q1 to Q2, we have transition, right? So in the same way, it takes an input string and transforms it. So So they can be used in both directions, generating the surface forms from base forms or deriving base forms from surface forms. So generally we say this as generation and analysis. So when I say generating surface forms from base forms, it is generation. And when I say deriving base forms from surface forms, it is called analysis. Suppose if you consider the transformation of a verb root into its past tense, like told you earlier also, the example, if you give walk, W-A-L-K, walk as an input, and you would get the output as walked, W-A-L-K-E-D, walked. So this means it is trying to make the root into its past tense. Then the FS, similarly, you can also try with some other verbs as well, similar to walk. So the FST might represent the rule for adding ed to regular verbs, which you are seeing right now in our example, that is walk and walked. So then applications of morphology and FSTs in natural language processing. So FSTs can be used. The first one is spell checkers. So FSTs can be used to generate all valid forms of a word. Example, plural tense, and check if a given word matches one of these forms. So spell checkers. So nowadays you can see many of your devices are coming up with these spell checkers, wherever it is suggesting you what is the correct spelling for that. Okay, then parts of speech tagging. So parts of speech tagging is quite important because it tells you the meaning or the grammatical meaning of a particular word, in what context it has been used. So FSTs, that is your finite state transducers, can aid in determining the parts of speech of a word based on its affixes. So whether it has an ed or ly. So just now in our previous example, we have seen walk have become walked, that is past tense. So in the same way, it also does this parts of speech tagging. Then machine translation. So morphological analysis using FSTs can help break down words into morphemes, making it easier to translate between morphologically rich languages. So when I say this morphologically rich languages, so it is like, there are certain languages which uses a wide variety of prefixes, suffixes, or infixes also, so to convey the different grammatical meanings. So generally, Finnish or Turkish, sometimes Hungarian languages are morphologically rich languages. Okay, then this is how the machine translation is also one application where our FSTs or morphology have its own mark. Okay. So then it is speech recognition. So morphological analysis helps in lexical lookup when recognizing spoken words, and FST can map surface forms to their base forms for better recognition. So this is about the speech recognition. And what are the challenges in morphological processing? So ambiguity is the challenge, where we have seeing this almost in each and every concept that we are covering. So many words in natural language are morphologically ambiguous. Example, flies could be the noun fly in plural, or the verb fly in third person. Got it? So disambiguating between different interpretations is a challenge. Then complex morphologies is the second challenge. Ambiguities you have been seeing in each and every concept that we are covering in our video lectures. Coming to this complex morphology is something new for you right now. So morphologically rich languages like Finnish or Turkish have complex inflectional systems which require more intricate FST. So when I say this word, so already I told you, so morphologically rich languages use a wide variety of affixes. I told affixes in the sense the prefix or suffix or infix, whatever, to convey some different grammatical meanings. So basically what happens here is, in these particular morphologically rich languages, a single word will express what would be an entire phrase in an English could do. So that is due to the extensive inflectional morphology that they have. Got it? So that is something which is a big challenge for this morphological processing. So hope you have understood the concept, students. Thank you.